So that actually did not take all that long to run for me. Did run through all 100 epochs, but it probably was a minute or less for the entire thing to train itself. So now we have a trained model based on the parameters that we have fed it. So what we want to do is visualize how it did. So this code that we're bringing in here is basically just kind of plotting four subplots that give us some information about how our model actually looks, and using the matplotlib plotting functions. So we're going to see something that looks kind of like this. So we see our loss function over time. We see our AUC, our precision, and our recall. Now, these are metrics which are very important if you're going into machine learning, where it basically gives you how reliable your model is, how many false positives there were, all of that kind of fun stuff. I glossed over it earlier, but this was the metrics that we fed into our model training set, the training of our model. So we have those, and now we're going to see something that looks kind of like this. And again, it's not going to be identical to the Codelab, but it's going to be fairly similar, right? So here we see our training, here we see the actual value. So we see that we're pretty reasonably close to our loss. Precision, we are somewhat close to. Recall, we are somewhat close to. Basically, we're just seeing that our metrics are similar, but not exact. And again, these are predictions we are drawing from past history to make a guess. Is a claim fraudulent or not? So we have basically visualizations of how our model is doing. So what we can do now is let's create a confusion matrix. And what this is going to tell us is very nicely how well our model does. So we format our data and we build our confusion matrix. Sorry, I skipped a step in my head. These are the absolute numbers for the correct and incorrect. So this one, we predicted 4004 correctly as non-fraudulent. This one was correctly predicted as fraudulent, so 512. And then we see here 80. Trying to get my X and Y correct here. There, let's restart. So here we're actually printing out our confusion matrix as absolute numbers. So on the top left, we see that we correctly predicted 4004 non-fraudulent charges, and then we correctly predicted 512 fraudulent charges. So basically, these two here are true positives that we were getting out of it. So effectively, it worked correctly. All right, so what we're going to do now is we're actually going to plot it. So we're going to set up our plot, and this is basically just all matplotlib code here for making the figure look nice. We're going to set our classes as fraudulent or not fraudulent. Now we'll get a nice pretty picture, which will give us a nice visualization of this. So confusion matrix, so we see not fraudulent, fraudulent, not fraudulent, fraudulent. So basically this is the true label, this is a predicted label. If we predicted not fraudulent and it was actually not, sorry, if it was actually not fraudulent, reading the row, and it was not fraudulent column, we did it correctly. Same down here. It's kind of hard to see. This is white text, but if it's fraudulent and fraudulent, correctly predicted this, we basically get percentages here. So we actually predicted 98% correctly there. Looks like in the Codelab it was about 96%, so our model did slightly better, which is nice. And again, I'm kind of intentionally skipping over some of these descriptions because they will be in the blog post about what all of these metrics are that you're going to hopefully be keeping an eye on. But if you need to really explain how your model is doing to somebody, and you just want a very quick figure to show somebody, confusion matrix goes a long way to help out with that. And looks like we hit 73%. It's kind of hard to see for correct predictions. So our model's not perfect, but it's not bad at this point. So we have a confusion matrix. So far, pretty standard machine learning procedures. We're using Keras. We're using TensorFlow under the hood. Nothing too crazy, out of the realm of possibility. If you're doing any kind of machine learning activity, you'd be doing something similar to this. So what we're going to do now is try and actually explain this model. Now, we're going to be doing this right inside of our notebook, which is handy as well. And a very important point here. By using this SDK, we don't have to go elsewhere in Google Cloud. One thing you might have noticed so far is that everything we've done, we've had to jump from page to page to page. Here we can do everything in the notebook, which is kind of nice. So let's save our model off to something called, or a directory called fraud model. All right, deprecated. Okay, next time, sure, we'll fix that. So we should have saved off our, yep, there it is. Just took a second to pop up. Here's our fraud model. It should look similar to hopefully before we see assets that we need in here. Oops, I don't want to upload. I want to go up a layer. Clicked the wrong thing. We have our variables. We have our model that has been saved off in an appropriate format. Life is good there. Okay, so let's use the call to get metadata based on our model. And this is getting into the SDK. So what we're doing is we're going to basically pass our model that we just exported into the explainable API. Let's run that. And we get some answers about our actual model. So we start seeing here, and it's kind of hard to read in my current format, I suppose. But we're getting tensor information. We're getting basically dictionaries built up that tell us what's going on. So explainability, great point here. This is answering why did the model think it was fraud. So we are deploying this prediction matrix. Why are we flagging things as fraud? If your customers ever ask you, why are you calling me with this fraudulent charge question? Probably they have a model. So first things first, to get this up and running, we need a baseline. And the baseline is going to give us a starting point for our predictions. So let's create our baseline. Basically, we're just kind of going back and formatting our data set here. So scaling our data, clipping, trimming off basically outliers, and then just taking the median. That's what we're doing here. Let's run that. What happened here? Not found in access. Did I do something wrong? Hmm. Okay, so one thing that I should mention here, if you're following along this Codelab, there's this step about finding the baseline. Now, this can help us with basically figuring out the median of our data set, basically a ground truth. If you skip this part with the explainable API, the explainable SDK, it's just going to assume 0 is your baseline, which we're going to use. And honestly, if you try to run this code, it will error out because we never create a not fraud sample data set, or data frame. So we're going to ignore this part for all of you. It should work just fine as you go. So skip this step. All right, so we have a model, and let's see. So we ran that. So basically I ran input name. So we're going to start building up our model to ship into the explainable SDK. So we're going to save that. We have now saved off our information into our fraud model database. We should see explanation metadata in here. And this is basically, again, the SDK inferring names of the various aspects of our model. So we have that. Now we want to load it into the SDK itself. So we'll go ahead and run that. get our local reference. Now, let's get some predictions. So basically what we're doing here is that we are figuring out the predictions and explanations for what was considered to be fraudulent. We're going to get something that kind of looks like this. And we actually do. Okay, so what we're actually looking at here is an explanation for why our model made a particular decision is a charge fraudulent. And if you look at this model, we're kind of looking at the older balance as being the main indicator for why a decision was made that was fraudulent. So we see kind of pushing past this 0.5 mark, and that's actually what's going to trigger the fraudulent claim. I'd recommend reading over these paragraphs here because it goes into approximation errors and baselines and fun things like that. But basically, this is how we're visually explaining what our model is leaning on. So these feature names were inferred from the metadata. Basically, they are the data frame headers that we have. So this is why, a particular decision was triggered. So to kind of pick back up with this, we can play around with these parameters for explainability. Really the important thing to get out of this, and again, for timing, we're not going deep into machine learning and what every single one of these metrics means, but we can generate figures which are going to explain why our models are making particular decisions. We can figure out what the approximation error is in our choices, and we can try to hopefully reduce false positives, reduce false negatives in our model decisions by going back and tweaking our model, tweaking how we're configuring it, changing the model that we're using, and even updating your training and your testing set, because one of the things with machine learning and models is that they are only as good as the training data that you give it. They only know how to experience or how to make predictions based on what they have already seen. And if you give it garbage data to train on, you're probably going to get garbage predictions. The other side is that you overtrain it, which is why in one of the first steps we balanced our data sets, because it would just automatically predict everything is not fraudulent because it has only ever really seen non-fraudulent data. So again, I'd recommend kind of digging into this Codelab because there's a lot of good examples in here. Now, the rest of these steps here basically deploy it to the AI platform prediction service. And I will leave this as an exercise to you if you want to kind of continue on with this. What we've done here in the Jupyter Notebook is really enough to sink your teeth into, but you can make this callable via an API or like a RESTful type of call. We can lean on our cloud resources to go ahead and run for us, but you're basically taking your model and deploying it to be accessible. So these just run you through some, kind of common G-Cloud commands to get it up there. And let's see, basically, again, you'll be interacting with it RESTfully, getting JSON responses, things like that. But I'm going to go ahead and clean up this notebook and leave the rest to you since we are already at 30 minutes untrimmed. And that's a lot for a simple demo. So I'll see you all next time. Hope this was useful. As always, hope you have a wonderful day.